Now, before getting into that procedure, I want you to know one thing which you might have studied before. If this is a beam and it is subjected to, let's say, 3 loads, P1, P2 and P3. It could be a UDL as well, but I just, for the sake of simplicity, I'm saying just 3-point loads. And I want you to find, let's say, displacement at this end B. Then this is just a separate problem. Okay, just want to explain one concept. So if I want to find this displacement at B, one way is that I have all these 3 forces acting simultaneously, present simultaneously, and somehow I start solving it, whichever method I like, I want to use, whichever method you like. But somehow you can find it dealing with all 3 at one time. The other way is what we call as a superposition method. And that way what you do is you break it down into something like this. So one force at one time, this is the entire span, P1. Maybe I could write it down just under it. So that principle of superposition says that you apply this P1 and determine this delta B. Let's call it delta B1 maybe. And then you can apply the next force, P2, and then again find delta B and call it delta B2. And then you consider the last force, P3, and then again you find delta B and you call it, let's say, delta B3. And now once you know these delta B1, 2 and 3, you just add them up. Delta B equal to delta B1 plus delta B2 plus delta B3. Okay? So this is called principle of superposition. Of course, you will acknowledge the fact that if, for example, one of these forces, I just want to reinforce the concept that this addition is an algebraic addition. Look, displacement is a vector quantity. You cannot simply say this term plus that term plus that term. You got to take care of the direction of displacement. If all of them are downward, you can simply say it sounds easy, you can just add them up. But if, for example, one of these forces were in the other direction, maybe if this was in the upward direction, then you would see that this P3 would be producing an upward displacement. Now, you cannot simply add up the 3 magnitudes together and get your result. That won't be, the right way. So how would you? So you got to take, when you're doing the summation of displacements, you need to acknowledge the fact that these are vectors, and you need to account for their directions. And one way to do that would be that you decide a sign convention. For example, I treat upward displacements positive, maybe downward displacement positive. I hope you understand this. It's my choice. I can come up with any sign convention I like. So I would say, so for example, I have a certain value for this. I call it A. The value itself is A. For example, 2 millimeter. This A is, that 2 value. Okay, getting it? So I have a sign with it. I have a direction with it. I have a magnitude for it. I have another value for this displacement, and I know its direction. Okay? And then for the third displacement, I know its value, and I know it's upward. So this equation is all right. There's no problem with that equation. So in this equation, we are treating this as a vector. This vector plus this vector plus this vector. Okay? So when you have to sum them up, and you use this sign convention, you got to write it like delta B equal to delta B1. If you treat downward displacement positive, you will say A plus this displacement is in the same direction as I treat positive. So I would say B. What next? Minus C. So it's actually like this, but I know you can put it up like this, minus C. I know why this. You know why this minus sign is here? Because this displacement is in upward direction, and in this equilibrium, this equation, I'm treating the downward displacements positive. Getting it? So just like in an equilibrium equation, when you have to sum up forces in certain direction, maybe x, maybe y, or maybe certain moments, you have to come up with your local sign convention for that equilibrium equation. Similarly, when you are summing up certain displacements, you have to make sure that you follow certain sign convention, okay? Because those are all vector quantities. So you got to take care of the direction, and that can be done by considering a sign convention. Now, coming back to the problem we have at hand,